Hi everyone. We're going to start talking about circles, and I have some already here on my paper so that I could just jump into the notes. So the first thing we're going to talk about are the parts of circles. And you might remember some of this from 8th grade, but the middle of a circle is called the center. From the center to the outside is the radius. And then when you go from one edge through the center to the other, like this is called the diameter. The diameter and the radius are related. The radius is actually half of the diameter. Or you can write it as the diameter is double the radius. But that's how those two are related. We also have something called a chord, where it goes from one edge to the other, but it doesn't necessarily go through the center. So this is a chord. And then we have a tangent line, which means it only crosses through one point on the edge of a circle. But that's a tangent line. So those are some of the parts. We are also going to talk about arcs. Let's start talking about minor arcs first. So minor arc, if you've heard of the word minor, think about like a child is minor. It's smaller. So a minor arc in this case is a smaller arc. And it's usually, well, it is smaller than a half circle. So I'm just going to draw that out. That's like half a circle. So in my diagram, I'm going to put some lines here. So let's say this is circle A. We have B, C, D, and E. So in this case, a minor arc, so anything smaller than half a circle, we could say from B to C, and you put the little arc on top. That would be this arc right here. Another minor arc would be like, I'm sorry, did I say E? I meant C, B to C. But we could also do B to E. That's a minor arc. We could say C, D, and E. This is actually not a half circle, right? It's smaller than it. So we can also say C, D, E. And that's another minor arc. Let's talk about major arcs. So if a minor arc is smaller than half a circle, then a major arc would be bigger than half a circle. I'm gonna draw this for half a circle. So this is anything bigger than half of it. If we look at our diagram, let's see. We could say from B all the way around to E. So B, C, D, E. That huge thing is one arc, and that's a major arc. It's bigger. We can say, let's see, from D going this way all the way around to C. If you just said DC, it would make me think, well, maybe you're just looking at this one. So you have to include the other letters. So we could say D, E, B, and C. Sorry. Okay, so that is major arc. And there's multiple answers here. I'm just kind of giving you examples. And then let's talk about a semicircle. Semi means half. And that's kind of what we were looking at here. It's half a circle. So our half circle here is from B all the way to D. It's exactly half. You can go this way or you can go that way. But that's a semicircle, so we can say BCD, or we could even go that way, DEB. And sometimes there's more than one. It just depends on the diagram you're given. One more thing. I'm going to give you an example down here. Before we get into this example, I know I kind of roughly drew it. One thing we have to know about circles is that they have 360 degrees. So that'll help us do this example here. But in this example, let's say this is 40 degrees. And usually that degrees goes with this space. So this part's 40 degrees. Let's say we have a right angle here. And they want us to find the measure of, let's look at TQ. The arc TQ. Well, TQ is right here, this space. Well, we see a semicircle, right? From RTQP. And if semicircle is half a circle, half of 360 would be 180. So maybe we should add that up here. Semicircles have 180 degrees. So this whole section has 180. We know this part's 40 and this part's a right angle, so this is 90. So we can make an equation. Let me put 90 here. So we can say TQ, the arc, equals 90 plus 40 plus we're supposed to be adding TQ. It's supposed to be equaling to 180. Okay, so if we add like terms, we know TQ plus 90 plus 40 is 130. Now if we finish solving, TQ comes out to 50 degrees. So that arc right there is 50 degrees. Well, what if this section here was x plus 10 degrees and we had to find x? So we can use this to make another equation because there's another semicircle right here, right? It's going across, so we know this section's 180. We just found this one as 50 degrees, so we can make an equation here. 50 plus 90 plus x plus 10 should be 180. and then just finish solving. So adding like terms, let's see, 10 plus 90 is 100, plus 50 is 150. Subtract 150. X should be 30 degrees. Oh, you can't see. Okay, so this is how we would do these kinds of problems. It might require you to make equations to find them, but that's how you would do that second IXL. All right, let me know if you have any questions, and I am available during office hours.